So today we'll discuss about the remaining portion of the material balance calculations for fuel pitch operation. So we have discussed till now how to find out the different streams LVGO, and part of VGO is LVGO and HVGO, then overflash and then pitch. So we have discussed all these things. Now the next step to convert these values into the whole crude basis, as we have discussed that these are the values on the basis of the feed of the vacuum. How we can do it? So we know that the feed is basically on the whole crude basis, it is from 51 to 100 volume percent, that is a 49 volume percent. So this is the whole crude basis. So we can develop a relationship between the whole crude basis and the feed basis, vacuum basis. So we can say that 100 points in the vacuum basis is equal to the 49 points in the whole crude basis. That is the range. This is the one relationship. With the help of this relationship we can convert. Let us see one example for that one. For example, this is a VGO. So VGO is about 63. So this 63 volume percent, that is the yield, or you can say the amount, it can be converted into the whole crude basis by this formula, 49 upon 100 multiplied by the 63.4, that gives equal to the 31.1. So this is the value that is equivalent to the 63.4 volume percent into the vacuum. So you have to put this value into the whole crude basis, and for that thing you can know that we can start from the 51. This is the initial point in the whole crude. 51, it is the starting point of the residue for the vacuum feed. So started from this one and add this 31.1 in this value, that gives the 82.1. So this is a range from 51 to 82.1 volume percent. This is a range for the VGO. So in this way we can find the range of all these streams that is given here. So this is a simple calculations method, and if you calculate it, these are the basically calculations. We can find yield in the whole crude basis. WC means whole crude basis. This will be 9.4, this will be 21.8, this is very close to the 1, the pitch value will be 16.8. Then the ranges, how the ranges can be calculated. These are the ranges of all these materials. After that, the next step, as we have already calculated all these next step, these columns in the atmosphere distillation calculations for the material balance, the first thing you should know about the yield and range. After yield and range, we can go for the mid volume percent for the calculation of API. So mid volume percent can only be calculated for the vapors, for the distillates. So VGO, distillates, LVGO, HVGO and overflash, all these are the distillates. Pitch is the bottom, that's why we don't need a liquid bottom residue. We don't need the mid volume percent. We have the graph 11 for the calculation of API of the pitch. After that we can go, this is given 17.1. All these values are calculated with the help of the graph given in the graph 1, and this value is given by the graph 11. So after calculating the API, we can convert all these values into the specific gravity, because our target is to convert all these values into the mass basis in the material balance. Then we can go for the molecular weight. So please remember that molecular weight can only be calculated for the distillates, not for the residue. That's why VGO, LVGO, HVGO and overflash, all these streams are basically used for the calculation of molecular weight. So molecular weight also calculated with the help of the simple graph or the equations that we have discussed in the atmosphere distillation column. And then come to the flow rate. This flow rate 49,000 is given. So on the basis of yield, because this is a 31.1, on the basis of yield we can find out these values, 93, 21 and 980 and 17, 934. These are BPSD values of the flow rates of every streams. So this is about the flow rate, but our main target is not about the flow rate in this one. Our main target is to calculate all these values into the barrels per hour. That is our first target. After that we have to convert that one into the pounds per hour. That is this is mass volume flow rate, this is mass flow rate, and the third one is a molar flow rate. So these are the three bases for the calculations in the material balance. So after calculating all these values, the BPSD, then we have to convert these BPSD into the barrels per hour, simply divided it by 24. After converting in the barrels per hour, we can find out the pounds per hour as we have did all these calculations earlier in the atmosphere distillation column with the help of the specific gravity and 14.9, and we have developed the formula that one also. Then next one is the molar flow rate. So this molar flow rate can be calculated with the help of obviously the mass flow rate, that this value, and the molecular weight. So number of moles is nothing but the amount divided by the molecular weight. But here the important thing you should know, we have only calculated for the 3 distillates. In fact, there are 3 distillates: LVGO, HVGO, and oroflash. These are distillates. As far as the VGO is concerned, VGO is nothing but it is a sum of LVGO and HVGO. So because we can take this VGO is divided into 2 parts, LVGO and HVGO, and we have to take the separate product of LVGO and HVGO. That's why we have calculated the molar flow rate of all these 3 separately, not by the VGO only. So this is all about. It's a very simple one. Thank you. These are some questions that can be arises during the calculations. For example, what is the slope? All are the condensed or flash. Drive the expressions for bottom stream required in the video. What are the assumptions taken for flash and tower based calculations? Carry out the material balance in terms of barrels per hour, pounds per hour, moles per hour for the given conditions. Find out flash zone pressures. Find out whether the column run under dry or wet mode. So this question we have to solve it in the later on. Otherwise, maximum questions can be solved by the given video. Thank you very much.